Yes, class. Am I audible to all of you? Abdul, Khadija, Leena, Nuha.
Yes, ma'am.
Okay. See, in the last class, we started with center of mass. Did you all appear for your after class assessment? I gave some questions based on center of mass only. See, rest of the questions, if you weren't able to attempt it, you'll be able to today because some of the concepts were left. Now, before we start, in the last class, we had discussed that center of mass is generalized formula is M1R1 plus M2R2 up till MnRn divided by the total mass. Means you just directly algebraically add all the masses. Fine. Now see if this is a trick to identify center of mass for two bodies. See if both the masses are equal, center of mass will lie in the center of the body. But just in case if center of mass, we want to find it for two bodies whose weights are not in the same ratio. So what we'll do? See, the center of mass will always lie near the heavier one. If M1 and M2 are two objects, center of mass will lie towards the near the heavier one. Fine, this is mass 1, this is mass 2. Center of mass is inclined a bit towards M1, where M1 is greater than M2. Also, class, one more note point before we begin that derivation, which I want to discuss. If you have variable center of masses, not center of mass variable masses, and we want to find out the entire center of mass, then what we do? So for that, instead of using M1R1 plus M2R2, what we do, we simply integrate x into dm divided by integral of dm. See what is meant by this. X into dm integration is exactly like m1x1 plus m2x2 up till mnxn. So for all the variable, you will be able to integrate. And integration of dm means all the small masses you are adding to get the total bigger mass. So that is also similar to the total mass. Similarly for ycm, integral of y dm, that will become integral of y dm by integration of dm. Similarly, zcm, center of mass for cm, that will be z dm divided by m. All right. Write down these points. Then we'll do this derivation. See class, like this question. Here you have a rod whose length is L and mass is M. Now we have to find out the center of mass for this. So for this, what we'll do, we'll take a very small element, dm, whose mass is dm and length is dx. This length is dx. The entire mass is dm. This is what we have taken. Fine. Now see, dm is infinitesimally small mass, means 0.00. Keep on adding 0 and then put a significant figure, this much of kgs. So you consider a small element of mass dm and length dx at a separation of x from the origin. Okay. Now see, when we have to find the entire one, I told you we'll use xcm is x dm, integration of dm. Now see, we'll integrate it from 0 to length L. See, integration of this dm will give us mass. This is fixed because the total mass is m. But what about x dm? How will you solve this? Because you cannot integrate it x square by 2 right now, because here there is no dx or there isn't any m. So we have to find out what is the meaning of dm. Dm is the mass of that small particle that we have taken, small portion that we have taken, whose length is dx. See, what was the mass of the entire length? Mass of the length is m. M is what? M is the total mass of the rod, right? M is the total mass of this rod. So what will be the unit length? This will be m by L, right? So mass of, if I want to take this very small portion, this dx, so this mass will be, this small portion, this mass will be mass of dx length. So mass of one unit is m by L. So for dx times, it will become into dx. What is the mass of dx length? Mass of dx length was dm. Remember, we started with this, that mass of dx length is dm, and we have found its value, ml by dx. Now you can substitute in here. So this becomes 1 by m was already there. X, instead of dm, we will write m by L dx, integrating it from 0 to L. So see, this m and this m will be cancelled. 1 by L, let's write. And now integration of x dx from 0 to L. This you can do now. So what does the law of integration say? X to the power 1, x to the power n is there. So n plus 1 will become. So 1 by L, keep it. This is already 1 here. So this becomes 2 divided by 2, 0 to L. What do? We put the upper limit first instead of x, L square minus. Then put the lower limit, 0 square by 2L. So this becomes L square by 2L. LL will be cancelled. So center of mass will be L by 2. Look, this is a symmetrical figure also. And for the symmetrical figure, we are getting exactly at the center. So what you have to remember? You have to remember that if you have regular or symmetrical shapes, like center of a circle, center of a square, center of a rod. So here, center of, this is just a straight line you can take. Center of mass will be always located at the center. Center of mass for this circle will be at the center. Not for every object. If it is unsymmetrical figure, then it's not necessary. Rectangle, so at the center of mass. So for proper shapes, proper center of mass will be existing at the center itself. Write down this. This is how you use for variable. Then one very famous question comes, which gets repeated a lot, that I'll discuss. If a portion is cut, then to find out center of See, from a disk of radius r and mass m. So there was this original disk of radius r and mass m. From this, a circular portion of r by 2 has been cut. And now if this is left, so which portion is left? This part is left. So we have to find the center of mass first. So whenever you're finding center of mass, always remember that you have to take an origin that will act as a reference. See, suppose this is origin. So this will be r by 2. This will become minus r like this. That's why we take an origin for the reference. Now see, if I have to find out the remaining center of mass. So how will I obtain the remaining part? Remaining will be the original disk whose radius is r minus the disk of radius r by 2, the smaller disk. See class, if from this original bigger one, if I subtract the smaller one, I'll be able to get this area, right? This area I'll be able to obtain. So remaining disk is original disk minus disk of radius r by 2. So the formula of remaining center of mass, this is m1 x1 minus m2 x2. This formula you can use, and whenever something has been removed, we usually write no plus. Just put a negative sign and your answer will be there. This is a formula which you can use to get these types of questions done, because these types of questions are very common. Now the problem that arises is m1, you will take it as m, original disk mass. x1, because we have taken this as the reference line. So at the center here, this is 0. So there is no separation. Okay, x1 will be 0. What about m2? That is the mass of this portion that is left. How will we find it? So what we can do, we can again apply unitary method. See, we know that mass of pi r square means the entire disk. Pi r square means entire disk is m. So unit area will be m by pi r square. So mass of pi r by 2 whole square will be m by pi r square into pi r by 2 whole square. So this becomes m by pi r square into pi r square by 4. Pi r square gets cancelled. We obtain m by 4. So second mass is m by 4, right? The second mass is m by 4. Mass of this part that is left. And what is the separation? Separation is r by 2. So x2 is r by 2. So you have all these 4 things with you now. Put it in this formula, you will get your final answer. In such questions, apply this only. Write it down. Now we'll see the concept. See, this is only radius portion we have done. Displacement part. We have velocity also. We have acceleration also. That we'll see now. Now see, motion of center of mass. So this was, until now we were just discussing the position of center of mass, right? Where the center of mass is located. So when I said in the last class that you have a body, in that body lots of particles are present, that's why the name of the lesson is also system of particles and rotation, right? So all of these bodies are present. So when the body will be moving with certain velocity, each of these will also be moving. This will be moving with some velocity. This particle will be moving with some velocity. This will be moving with nth velocity. Like this, you will have all the velocities. This will be up till nth equation, right? So for velocity, how will you obtain velocity? If you have displacement, one law that we use for displacement to get velocity is just simply differentiation. Rate of change of displacement is actually velocity. So if I have radius of center of mass, velocity of center of mass will be simply differentiation, rate of change of this position. Position vector, differentiate it, you will obtain velocity. So what do I have to differentiate? I have to differentiate m1 r1 plus m2 r2 up till mn rn over dt, with this m is there already. So velocity of center of mass, this will be, see, 1 by m is here. When we'll differentiate, see, m1 is a constant term, so it will come out. What we'll be left with? dr1 over dt, correct? From here, then plus again m2 will come out, dr2 over dt. So like this up till d mn, not dmn rn, mn will come out. This mn will come out, then drn over dt of this will come out, right? This is what we have. This is what we have. So look here. dr1 over dt, dr2 over dt, drn over dt. Can you see? This is basically velocity. This is v1, rate of change of displacement, dr over dt. This is v2, this is vn. So what is the final formula for this? Look, final formula will become v center of mass will become, this becomes m1, we are left with m1, and this entire term is now v1, plus then again m2, this entire term is v2. So up till this will become mn vn divided by m1 plus m2 up till mn, which is the total mass, that is m. So isn't this formula similar to position vector 1 only? It's just that we are having velocity where we were having the value of it. Fine, this is it. This is how you have to write the center of mass. This is the velocity of center of mass. Fine. Now see, if I further differentiate, what do I get? What do I when I differentiate this? What do I get? See, acceleration of center of mass. Fine, this is acceleration of center of mass. So acceleration of center of mass means you are differentiating velocity. If you further differentiate velocity, you will get acceleration. So d m1 v1 you are differentiating, plus m2 v2 you are differentiating, up till mn vn you are differentiating over dt, right? With this total mass is m is the total mass, so m is also there, right? We are differentiating this. So when you are differentiating, again same thing will occur. For acceleration of center of mass, 1 by m will be there. Now m1 is constant, we are left with dv1 over dt, plus again m2 is constant, dv2 over dt. So up till mn dvn over dt. So what is this? This becomes acceleration 1. This becomes acceleration 2. This becomes acceleration nth. So what is the final formula we get for acceleration of center of mass also? Can you see this is exactly the same again? m1 a1 this time plus m2 a2 up till mn an divided by total center of mass. So these are the formulas are exactly the same. When it was radius, so m1 r1. When it was velocity, m1 v1. When it is acceleration, m1 a1. We'll see questions on this also. First, write down this. See, in this question, one block is going up. This is pulley mass problem. We have seen acceleration upwards is given to you to take it as negative. This is acceleration downwards positive, 10 kg mass is there. So we have to find out acceleration of each and acceleration of center of mass. The actual acceleration is calculated as the net balanced force by the total mass. The actual value of acceleration. See, if you draw FBD, please revise pulley mass problem for this. This will be 5G, mg. This will also be mg downwards. We take the forces along acceleration as follows. This is tension. See, this would also be positive, not negative. Acceleration is upwards. So this becomes T minus Fg is equal to 5G is equal to 5A. So 5 into this becomes T. Oh, no, for the second equation also let us write. If we'll have both the equations, then we'll be able to solve it. So this is downwards. Here tension is acting upwards. So towards the acceleration, we take it as positive. We have done this in detail in laws of motion. So 10G minus T is equal to 10A. You have both of these equations, use and find acceleration, or simply use net balance force will be 10G minus 5G. Total mass is 10 plus 5. So that becomes 5G by 15, which is equal to G by 3. So acceleration 1 for this first acceleration will be minus G by 3. Second acceleration will be plus G by 3 because we are finding the acceleration. One acceleration has to be taken positive. In the question, originally it was given this, no? This I just put it plus to show you this so that you don't confuse with the actual sign conventions. In the question, it has told you to take one acceleration as negative, means to take this. So that you do not take it over here negative. That's why I marked it as positive for the time being, so that you don't get confused. Now you have both the accelerations, you have both the masses. So acceleration of center of mass will be m1 a1 plus m2 a2 divided by m1 plus a2. See, one mass is 5, acceleration minus g by 3 plus mass 10, acceleration plus g by 3 divided by total mass is 15. So this becomes C 10g. This is minus 5g by 3. So here only 5 is left. So g by 9. G by 9 is the answer of acceleration of center of mass. So these are the individual. This is the cumulative acceleration. Write it down quickly. we have to find out velocity of center of mass. So see, one direction we'll take positive. In the question, it has specified to take right as positive. So this velocity will become positive. This velocity will become negative. So m1 is 2 kg. v1 is 5 meter per second. m2 is 5 kg. See, v2 will not be 2 meter per second. Instead, it will be -2. Now use the formula of VCM. m1 v1 plus m2 v2 divided by m1 plus m2. So this becomes 2 into 5 plus 5 into -2. 5 into -2 divided by 2 plus 5. So 5 minus 2 is 10. This is 10 in 10 plus -2. That is 10 minus 10. So it is 0. So answer for this is 0. Write this down quickly. Some portions I have skipped in between. We'll do this later. First, just focus on this because this is a continuation. Conservation of momentum of center of mass. So see, center of mass is momentum, that is mass into velocity. That will be calculated by simply adding it. All right. So, and how do we calculate the force? If you remember Newton's second law, force is rate of change of momentum. So rate of external force will be rate of change of momentum over here also. All right. Now, in an isolated system, you just have to remember that external force is zero. See, this external force is zero. So if this external force becomes zero, dp over dt will be zero. It means there won't be any change in momentum. This value will be constant. PCM will be constant. Like I'll show you a question. Look at this. This is that if the child jumps off the car towards right with a velocity u with respect to ground, find velocity of the car after the jump. See, center of mass's momentum will be conserved. That's what we have seen. So initial mass into velocity minus the mass and velocity of this. Let's say this is moving with v velocity. So that becomes mv. Right? So initial momentum is equal to final momentum. What is the initial momentum? See, mass of the child is small m. Velocity with which the child falls off is u. Final momentum will be mass of the car because now the car is left. Car is, it's like if this is jumping, so this will move a bit behind. So what is this? This is mass into v. So what is the value of velocity? mu divided by capital. This is just a small topic that I wanted to discuss, conservation of momentum of center of mass. So you just have to see initial momentum is equal to final. Write down this also. You all can attempt your after class assessment. The portion that is left in between is force. Acceleration we have obtained, so force has to be calculated. That I'll discuss it in the next class now. All right. And then we are left with in rotation.